Welcome to this video about SerializeReference, a relatively new feature in Unity. But to understand SerializeReference, we first need to do a quick recap of serializeField. As you probably know, you can mark variables with the serializeField attribute to have them save their data and make them editable in the inspector. We can do this for most basic classes and structures, and you can use the values gettable from the serialize property class as a guideline. You might have already done this when writing custom inspectors. It's pretty much anything you can break down and write as a string. What you also probably know is we can make our custom classes serializable with the system.serializable tag, and then in turn mark its fields as serializable, which means we can now have instances of this class visible and editable in the inspector. One quick note, if you do this, it means the reference to that class will hardly ever be null, as upon serialization, a blank or a default instance of that class will be created. This is especially dangerous when you have private references to serializable classes, which means they are null until you use the debug inspector to view them, which can be really hard to debug and sort of like a Schrodinger's error. Anyway, what are the limitations of serializeField? Firstly, there's a depth limit. When you make a class system.serializable, it simply becomes a container in the saved JSON. And as mentioned, Unity fills these serializable classes with a default empty instance. So if you have a serializable class with a field in itself of its own type, and then it tries to serialize that, it will loop forever, trying to populate the class, and then its fields, and then its fields, and it will just go on forever. Instead, Unity has a depth limit, which stops this behavior. This means you can't have too many serializable classes inside one another, and can never have a class with a field of its own type. This is really annoying if you want to have any kind of tree-based structure, where one node references another node, which references another node, and it goes on. That will be infinite, and you can't serialize that. The second issue, serialization of subclasses. When using polymorphism, it's quite possible to have a subclass, in this case B, be stored inside of a field of superclass type A. However, when using serializeField, upon reloading, the field will have regressed to type A, losing the functionality and any data contained within the subclass type B. This also applies to lists that might contain types of A, B, and C. After serialization, they will all be of type A. That's really annoying. However, it is worth noting that this is unlikely to happen, as the Unity inspector will by default populate these lists and fields with the base type. So it'll be quite hard to get types B and C into a list of type A without doing some sort of custom inspector or editor tool. So, SerializeReference. SerializeReference simply does what it says. Rather than storing the data directly by simply writing down the values, it serializes where the data is, the reference. This allows us to get around these earlier issues. So, the depth limit. Before, we had our nodes referencing nodes. Unlike serializeField, serializeReferences can't be seen in the inspector, and it isn't automatically populated with an empty instance. It can be null. So that can be dangerous, but also means there's no issue of infinite depth. For our nodes previously, we probably would have had to use iSerialization callback receiver, store all of our nodes in an array, and then have each node reference the index of its other nodes, whatever. It's complicated. But with SerializeReference, the direct reference is stored, so we can just reference one node to another node, just like we would like to if we were designing in another language and not having to worry about serialization or saving. However, again, these SerializeReferences are not editable in the inspector, so you will need to build an inspector or tool that populates your structure. For issue 2, the serialization of subclasses. Because serialization stores where data is, it can directly reference the subclass every time, so no data is lost. There's not going to be any issues of regression. It's always going to be the type that you saved it as originally. This means we can have fields and lists containing different subclasses simply using SerializeReference. However, again, SerializeReference is not viewable or editable in the inspector. However, this makes sense, because if you had a field of type A, how would the inspector know to populate it with A, B, or C? Same with a list. However, I have actually created a list that will allow you to populate a list of type A with Bs and Cs and Ds, and with a drop-down, and that's covered in my other video with Unity store link and GitHub. They're all below as well. My socials are linked below, and my coffee if you'd like to donate.